Welcome to the essay practice series first video. So in today's video we will be, now I have already sent the PDF onto the WhatsApp group. So now today we will be discussing about this organic question. Okay, organic question. This is a question number 8 of a model paper. Question number 8. Okay, the question is identify A1 to A5, B1 to B4 and C1 to C3. Okay, I need to identify those species in order to complete the following reaction series. In the first reaction, Lamai, now this is what happens first. Now C6H5, C6H5 means it is a benzene ring. It is a benzene ring. Then attached to C O N H and another benzene ring. CH double bond CH CH3. Okay. The first reaction they have done is adding NaOH first. NaOH and then H plus H2O. H plus H2O. Okay. Now I'll explain the theory here. Now when NaOH is added, now this is the compound. This is the compound, okay? This is the compound. This is a rough diagram, okay? So I'm just writing it faster. When NaOH is added, this Na, NaOH. Okay, this NaOH, this NaO part will go and combine with this. Oh, there's an oxygen. Yeah, this NaO part will go and combine with this carbon. I'm not going to explain the mechanism because the mechanism is not needed at the moment. This NaO part will go and attach with this carbon here, and this hydrogen, I'll draw properly again, and this hydrogen will go and combine with this NH while breaking the bond. Okay, that's what NaOH will do. So what will be the end product now? NaO in NaOH will go and combine with this CO double bond. Okay, with the carbon, and the hydrogen will go and combine with the NH. Okay, so the final product will be and while breaking the bond. So the final product will be O minus Na plus and NH2 CH CH3. So the reaction doesn't stop here. I also have added H plus and H2O, right? I have added H plus and H2O. So when we add H plus and H2O, nothing will happen here. But here this will happen. Okay, C O O H and NH2, nothing is happened here. Okay, CH CH3, nothing has happened there. So these are the final products of this reaction. So this can be B1 or C1. We don't know. We will know it at the end. Okay, not at the end, while I'm explaining the next part. Okay, B1 or C1. Now Lamine, now let's consider the end product, or as a final product. Let's look at the final product first. Now we have NO2 CH N N sorry, a benzene triple bond carbon CH3. So what are the changes that have happened here? From here, let's say from here to here, what are the changes that have taken place? So now this is a carboxylic group now, and this is an aniline group. Okay, this is an aniline. NH2 attached to benzene is called aniline. So for NH2, Lamai, now this is the theory. This is the theory. Okay, the theory is, I select blue color. The theory is for an aldehyde. For an aldehyde, for an aldehyde, zoom in a little bit. This is the theory. I'll go to the new page. For an aldehyde, when NH2 R R can be R can be alkyl or benzyl group. Okay, benzyl group. For an aldehyde, when an NH2R group is added, now this is the end product. Okay, RCOH. When NH2R is added, we will get RCH, double bond nitrogen R, R dash. Okay, R dash. This R is not similar to this R. Okay, even if it is similar, it doesn't matter. I just want to explain, like, if there is this NH2 group and you add this to an aldehyde, you get this as a final product. Now you will ask, sir, what if a ketone is there? Then if a ketone is there, R plus NH2 R dash, this will happen. Okay, R C R, double bond nitrogen R dash. Okay, this is what you will get. So now finally now we have this one. In order to get this, now you can see this is similar to this one. No, this is similar to this one. This is similar to this one. So to get this compound, I need to make this guy an aldehyde, and this, in this part, I just want to make this double bond a triple bond. Okay, I just want to make that double bond a triple bond. Okay, for this one, the difference that we have to make is make the double bond to a triple bond, and here I have to convert it to an aldehyde. Okay, now we can figure out how to make them. So now in this part you have to think. Okay, you have to think in this part. Now B series has 4 steps. 1 2 3, no, 3 steps. C series has 2 steps. So you have to find out whether RCOH, you have to find out whether, you have to find out how those things are formed. Okay, now I will do like this. I will consider B1 is B1 is this one. Okay, this carboxylic acid double bond. B1 is OH. Okay, so if B1 is OH, I want to convert this guy into this one of NO2 COH. I want to convert it into this. Okay. Then the first step will be, now this must have three steps. Now because I'm considering B1 is this one, it will have three steps. Okay. It will have three steps according to my consideration. Three steps තියෙනවා නම් three steps තියෙනවා නම් we will start with this no OH. So I can start by adding a nitro group. Nitro group. How do I add? Conc HNO3, conc H2SO4, heat it to 50 degrees Celsius. No, 50 degrees Celsius. Then I will receive this one with an NO2 group attached to the meta place because this is a meta director. Okay, this is a meta director. Then I should convert this carboxylic group into now I have to convert this carboxyl group into an aldehyde. Therefore, for this one I will prefer adding, let's say I add LiAlH4 and then H plus H2O. This will be converted like this, CH2OH, and then for CH2OH if we add PCC we will receive hot tail. I will receive NO2 COH. Yeah, I got what I need. In how many steps? In how many steps? 3 steps. 1, 2, 3. So according to my consideration, can B1 become this group? Can this be B1? Yes, this is B1. Then who will be C1? Now that's my consideration. If I consider B1 as the other group, if I consider this one as B1, then the results will be different. Like you will get it in 2 steps, as we will see in the next C part of the C series. Then C1 will be NH2 CH CH CH. Now I need to convert this into a triple bond. So first I will add Br2 aqueous. Then what will happen? And Br2 aqueous CH Br CH Br CH3 is obtained. So for this, when I add alcoholic KOH, I will receive NH2 C triple bond C CH3. Okay, so therefore this is C1. This will be B1. Okay, This is C1 and this will be B1. Sorry. Yeah, C1. So how will the answers be made? Identify A1, A2, A3, A4, A5. A1 will be no B1 to B1 to this one, then conc HNO3, conc H2SO4. Then A2 will be this is A1, this is A2, and this is A3. You can write like this. H plus H2O. So A3 will be this one, PCC. A4 is this one, Br2 aqueous. A5 is this one, alcoholic KOH. Alcoholic KOH. Okay. Then we will check and see who is B1 to B4. No? B1 will be this guy. Then B2 will be uh, a nitro group attached to this B1. A nitro group attached to B1. Then B3. B3 will be nitro group over here, CH2OH. Then B4, aldehyde and a nitro group. Aldehyde and a nitro group. Then C1. C1 will be NH2, again a heart. CH, CH, CH3. C2, NH2, CHBr, CHBr, CH3. C3 will be NH2, triple bond C, CH3. Okay. This is C1, C2, C3. Okay. Then we will go to the next question. Question number B. Question B. Question B. Now they are asking convert this CO into CH3, CH3, CO, O, CH, CH3. Okay. Now Lamai, remember, start from behind. Start from behind. Not like this, okay? You have to start from behind so that you can figure out, okay, from where I should start. If you start from here, you will start to, I mean, confuse yourself. So always start from behind. Okay, I have this compound, but I have to start on using this one. But only the chemical substances given below I can use. I cannot use an external organic compound cannot be used. Cannot be used. Okay, external organic compound cannot be used. So remember that point. So with using this, I have to create this one, and it cannot exceed 7 steps also. So now I look at here. There are 3 carbons over here, 3 carbons over here, no, 3 carbons over here. So there are 3 carbons here. If I use if I use two of these, two species created by this, and combine them, I can form this guy. I can form this guy. Okay. Now, for carboxylic acid, RCOOH, for carboxylic acid, if you add this group, CH3, CH3, if we add this group by adding conc H2SO4, you can form this one. You can form this product. You can form this product. Okay. From this one to here, it is a CH2. You can form this product. So if it is a RCOO, so CH3, CH2CO, Cl, you don't need to add conc H2SO4. You don't need to add conc H2SO4. So by having the reagents, we will try to figure out whom can we make. This one or CH3, CH2, COOH and CH3, CH, CH3. I need these, either this or this and this one, okay? I need to form them. I need to form them. CH2. Okay, now we'll start with the first step. For this group, I need to make this one. I need to make this one. If I add LiAlH4, if I add LiAlH4, I want to reduce it. We should use the substances given, okay? So I need to reduce this to an alcohol. My first step is reducing this to an alcohol. Okay, reducing this to an alcohol. We need a reducing agent. What is the reducing agent given? NaBH4. And what do we want? NaBH4 and methanol. Sorry, NaBH4 and yeah, methanol. Mm, now students, you first in this step you have to add NaBH4. We need to reduce the what are the two reducing agents we know? NaBH4 and LiAlH4 H plus H2. So here I am using NaBH4. NaBH4. Then I get this compound. We have to add methanol since methanol is not there. Now methanol is this no, it's not given, so we don't add anything. NaBH4. Then from this one I can form. I need to form I need to form CH3, CH2, COOH and CH3, CHOH, CH3. If these two are there, then I can form this guy, okay? I can form the final product. So we already have one part. We already have one part. The other part we need is this one. So we will try to form him. So next step we will add. We have to convert this into a terminal carboxylic acid now. Let's try adding conc H2SO4 among the compounds given conc H2SO4 and heat it. So we will get CH3 CH CH2. Then we will add uh, among the compounds given, we can add aqueous NaOH, not aqueous NaOH. We can add HBr. We can add lamine, HBr, HBr and like this, CH3 O CH3, a peroxide group. Okay, you can remember, no, like if we add HBr or HCl in an H2O2, okay, in a H2O2 peroxide medium, we will form a terminal CH2 CH2Br. If this is not there, now this is similar, okay, similar, this is similar to this one, this is similar to this one, to H2O2. So if you think like that, if H2O2, this is CH32O2, something similar now. If H2O2 is added, usually before, if H2O2 is not added, hydrogen will go and bind to the place where hydrogen is more, which is known as Markovnikov's theory. Markovnikov's theory. It will go and bind to the place where hydrogen is more. But when a peroxide medium is added, when a O2 minus peroxide medium is added, like in this case, uh, we get the hydrogen will go and bind with the carbon who has less hydrogen. Okay, anti-Markovnikov's theory. You must know this one. Okay, you must know. It's a must know fact of organic chemistry. And then I will add NaOH aqueous. NaOH aqueous. Convert this to an alcohol, CH2OH, and then I can add H plus KMnO4. Then we will get CH3 CH2 COOH, and then you can write like this, conc H2SO4. How many steps are there? Let's count how many steps are there. 1 step, 2 step, 3, 4, 5, 6. Okay, within 6 steps we were able to, we managed to form, from among the compounds given, we managed to form the product that they asked. Okay, then the next part, I will do only C1. Give the mechanism of the reaction below. Okay, CH3 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 Br plus NaOH. Now this is a tertiary alkyl halide. Tertiary alkyl halides will undergo nucleophilic substitution in two steps. Now this is a nucleophilic substitution. This is a nucleophilic substitution reaction. Okay, this is an example. This is the nucleophile, and it will be substituted with this one. Okay, bromine. So this is a nucleophilic substitution reaction. But for primary, but for but primary and secondary alkyl halides, nucleophilic substitution occurs in one step, okay? That means for tertiary alcohols, it's say R, C, R bromine plus OH minus. This will attack this carbon first. Sorry, what happens is when you add OH minus, first this electron from the bond is broken and gone to bromine. Then R, C, O, R plus Br minus plus OH minus is there. So this OH minus then will attack the C plus here and form RCr OH and Br minus. Okay, this will be the product. So why I told you in primary and secondary alkyl halides a carb, now here a C plus is formed, no, a carbocation is formed because the tertiary alkyl halide or tertiary carbocations are stable. That's why uh, this can happen in two steps, and primary and secondary alkyl halide nucleophilic substitution must occur simultaneously. That means, let's take an example really like this. Let's take an example. CH3, CH2, CH2Br, CH2Br, and OH minus. OH minus must, now here it will be partially positive and partially negative. This guy will attack here and this bond will break and go here. This bond will break and go here. This will occur simultaneously. Not like the bond is forming first. Let's say like this. Bond is forming first and forming CH3, CH2 plus. It is wrong, okay? Why? Because primary carbocations are unstable. Okay, unstable. Therefore, it is not formed. Therefore, the answer for C1 will be CH3, 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 Br plus OH minus. First, this is how you draw the mechanism. C, CH3 plus. Now plus will be there, okay? Plus B, OH minus, Br minus is there. Okay, leave the Br minus aside because OH minus will attack him and form CH3, CH3, OH, and Br minus will be a byproduct. This is a byproduct. Okay, okay students, that's all for today's discussion. Okay, thank you.